Alright, since you already know the general equation of both potential energy and kinetic energy, the next part of the lesson is about solving worded problems. Make sure to follow the steps of worded problems. Let's begin with the word problem on potential energy. A car of mass 23 kg is traveling down the hilltop of height 108 meters. What is the potential energy? After reading the problem carefully, look for the given data in the problem. The given are mass 23 kg, height 108 meters, acceleration due to gravity, which is constant, is 9.8 meter per second squared. So after taking note of the given, look for what is asked or the missing variable in the problem. In this case, the potential energy equivalent in joule. Now, in getting the value of the potential energy, we need to use the equation. Potential energy is equals to mass times acceleration due to gravity times height. All you have to do is to substitute all the given data. Mass is 23 kg times 9.8 meter per second squared to acceleration due to gravity times 108 meters for height, and the answer is 24,343.2 joule. Next is the potential energy word problem in height. A box has a mass of 8.5 kg. The box is lifted from the floor and placed on top of a shelf. If the box gains 195 joule of potential energy, how high is the shelf? Again, read the problem carefully and look for the given data in the problem. For mass, we have 8.5 kg, 195 joule for potential energy, and 9.8 meter per second squared as acceleration due to gravity that is constant. Upon taking note of the given, look for what is asked in the problem. The missing variable is the height in meters. In getting the value of potential energy, we need to use the equation of potential energy, which is mass times acceleration due to gravity and height. Using the triangle method and knowing that the missing variable is height, just cover the symbol of height so that we are left with potential energy over mass times acceleration due to gravity. Remember that horizontal is multiplication and vertical is division. Therefore, the formula for height, potential energy divided by mass times acceleration due to gravity. Going to the next step, substitute all the given data. We have 195 joule divided by 8.5 kilograms times 9.8 meter per second squared. Multiply first the variables of mass and gravity. We have 83.3 kilogram meter per second squared. Dividing the variables, we have the height of the shelf equals to 2.34 meters. Let's proceed now to potential energy word problem in mass. A man climbs onto a rocky mountain that is 3.6 meter high and gains 2,268 joule of potential energy. What is the mass of the man? Read the problem carefully and look for the given data in the problem. We have height is 3.6 meter, potential energy is 2,268 joule, and 9.8 meter per second squared, known as acceleration due to gravity, which is again constant. Upon taking note of the given and look for what is asked in the problem, which is mass in kilogram, and knowing that the missing variable is mass, we can use the triangle method to easily find the solution. So, covering the symbol of mass, we are left with potential energy, acceleration due to gravity, and height, showing vertically, which means division. Therefore, the formula for height is mass is equals to potential energy divided by acceleration due to gravity times height. Next is simply substitute all the given data, so we have 2,260 joule over 3.6 meter times 9.8 meters per second squared. Multiply first the variables of gravity and height, and the answer is 35.28 meter per second squared. Dividing this to potential energy, we find the mass of the man equivalent to 64.29 kilogram. So, without further ado, let's solve for kinetic energy word problem. Determine the kinetic energy of a 1,000 kilogram car that is moving with a speed of 20 meters per second. Analyze the word problem carefully and look for the given data on the problem. We have mass of a car, which is 1,000 kilogram, and the speed of 20 meters per second. Next is to find the missing variable in the problem. In this case, the kinetic energy, which is equivalent to joule. And getting the value of kinetic energy, we need to use its equation. In proceeding with the substitution of data, we have potential energy of 1,000 kilogram and 20 meters per second of velocity squared. Since we have the velocity squared in the formula, this only means that you have to multiply 20 meters per second by itself to get 400 meters per second. Then multiply this to 1,000. We derive the 400 kilogram meter per second. So 1/2 of 400,000 is 200,000. Thus, kinetic energy of a moving car is 200,000 kilogram meter per second, or 200,000 joule. A tennis ball is traveling at 50 meters per second and has a kinetic energy of 75 joule. Calculate the mass of the tennis ball. Carefully look for the given data in the problem. We have a tennis ball traveling at 50 meters per second and its kinetic energy of 75 joule. Next, finding the missing variable, which is the mass of the tennis ball. In getting the value of mass, we need to use the equation of potential energy. Thus, we derive the equation for the mass by transposing. In this manner, our solution for mass is 2 times potential energy divided by the square of velocity or speed. To substitute the given data, we have 2 times 75 joule over 50 meters per second squared, with velocity multiplied by itself to get the sum of 2,500 meters per second. Then we divided the kinetic energy of the tennis ball, which is 150 joule, to its velocity, which is 2,500 meter per second, so that we get its mass of 0.6 kilogram. So last but definitely not the least, we have kinetic energy word problem in speed or velocity. A man is transporting a wooden cart of mass 6 kg and having kinetic energy of 40 joule. Compute its velocity with which he is running. Carefully look for the given data in the problem. We have a mass of a wooden cart of 6 kg having a kinetic energy of 40 joule. Then look for the missing variable in the problem, which is the velocity or speed in meter per second. In getting the value of velocity or speed, we need to use the equation of potential energy, of kinetic energy rather. Thus, we derive the equation for the mass by transposing. This way, we solve for velocity as the square root of kinetic energy divided by mass. To substitute the data, we have the square root of 40 joule over 6 kilogram. Find first the square root of kinetic energy. We have 6.32 joule and divide this by 6 kilogram so that the velocity of a man transporting a wooden cart is 1.05 meter per second. So that's it. Every day, whether you notice it or not, we are all busy converting potential energy to kinetic energy. Maybe your perception of the word potential is different from everybody else's. Still, every person has potential to achieve what they aspire. Dear learners, little accomplishments like school grades give glimpses of potential energy, as quality and measurable outputs depends on how much learning one gets converted to kinetic energy. We'll have the energy of what can be and the energy of what is. Depends on the opportunity or adversity life brings. In other words, we have the means to transform our creative potential into meaningful action. Start honing your own unique potential now and create kinetic energy in faith and glory. That is all for today. I hope you learned something. If you have questions, please do in the comment section below. You may like and share if you ever do. And if you wanted to avail my other video lessons for, just hit the notification bell. Thank you for watching and definitely enjoy studying. God bless and see ya.